Let's go ahead and start. Cover material for the first hour and a half or so, and then I'll shut off the recording, and I'll then answer any questions you have. Section 1.1, linear equations and rational equations. First thing we'll take a look at is solving linear equations. So solving linear equations in one variable. We have a note that goes up at top. It says at any step, combine like terms and combine numbers. Our first step says to get rid of parentheses. And we do this via the distributive property. Second step, we get rid of fractions. We multiply by the LCM of all the denominators. Third step, get everything with an X on one side, numbers on the other side. When I say everything, I'm talking about terms. Step 4, divide both sides by the number in front of the X, although you can have any variable. So let's take a look at an example. If I had 4 times x minus 2 plus 3 is equal to 7x. Step 1, get rid of parentheses. And I said we do that via the distributive property. So we'll take this 4 that's in front of the parentheses here, and we'll multiply it times x, and multiply it times negative 2. 4 times x is 4x, 4 times negative 2 is negative 8. I'll bring down everything else. Plus 3 equals 7x. Our note up at top, at any step combine together numbers. Negative 8 plus 3 is negative 5. Step 2, get rid of fractions, don't have any. Step 3, get everything with x on one side, numbers on the other. So I'll take this 4x and move it over, and we end up with negative 5 is equal to 7x minus 4x. When you take anything across or equals, your sign changes. Our note says that any step combine together like terms. Like terms is where you have the same variables to the same power. 7x minus 4x gives us 3x. Step 4, divide both sides by the number in front of your x. Number in front of x is a 3, so we'll divide both sides by 3. And that gives us negative 5/3 is equal to x. These 3's cancel. Now let me make up one with a fraction. 1/6x minus 3 equals 1/4 x plus 1. Excuse me. Step 1, get rid of parentheses. Don't have any. Step 2, get rid of fractions. Multiply everything by the LCM of all your denominators. Now we got 6 and 4, so we're going to multiply everything by 12. So you take 12 times 1/6x. We'll take 12 times negative 3. 12 times 1/4 x. And 12 times 1. Now when I say multiply everything by the LCM, I'm talking about separated by pluses, minuses, and equals. So that's why we multiply by the 1/6x. Here's a minus, so that's why we multiplied it by the negative 3. Here's an equals, so that's why we multiplied it by the 1/4 x. And here's a plus, that's why we multiplied it by the 1. 12 and 6 are both divisible by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. 4 and 12 are both divisible by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. We're left with 2 times 1, 2x. 12 times negative 3, negative 36. 3 times 1, 3x. And 12 times 1, 12. Step 3. Get everything with an x on one side, numbers on the other. I'm going to take the 3x over the left side on this one because I want to demonstrate something. I'll take negative 36 over to the other side. Again, when you take anything across your equals, your sign changes. The positive 3x becomes a negative 3x, and the negative 36 becomes a positive 36. Combine like terms. 2x minus 3x is negative 1x, or negative x. 12 plus 36 is 48. Now our last step. Divide both sides by number in front of your x. Number in front of x is a negative 1, so I divide both sides by negative 1. 48 divided by negative 1 is negative 48. Now what I was demonstrating here is how do you handle it when you got a negative in front of your x? Sometimes people don't know how to deal with that. But remember, if it was a negative x, it's still a negative 1x, so you just divide both sides by the number in front of your x. Let me clear that off. And that was solving linear equations. Now identify conditional equations, identities, and contradictions. Okay, let's say I'm working a problem down. Going along, those are steps you can't see, and I come up with an answer. If you come up with an answer, that's a conditional equation. It means that the original equation is conditionally true when x is equal to 3. It's the only time it's true. The next one is identities. So these indicate steps you can't see. You're working a problem down, and all of a sudden your x disappears. And you get 2 is equal to 2, or 1 is equal to 1, or 0 is equal to 0. If you get the same number equal to each other like this is an identity. I always like to think of it, when is 2 equal to 2? Always, which means that your answer always works. And our last type, the contradiction. Working a problem down, all of a sudden your x disappears again. You end up with something like 1 is equal to 2, 2 is equal to 7. Something that can't be true. Again, when the question is, when is this true, and the answer is never, that means it's a no solution. And the book uses the term contradiction. Means there's no answer to the original equation. Let me erase those now. And let's take a look at solving rational equations. Solving rational equations. Step 1, get rid of parentheses. Step 2, get rid of fractions. And in order to do that, first thing you do is you factor all your denominators. Second thing you do is you figure out the LCM of all the denominators and multiply everything by it. Now, third step is solve for x. Now, it could be a linear equation in which you use the four-step method, or it could be a quadratic equation, and you use the zero factor property. We'll see that zero factor property a little bit later on in this video. So let's take a look at one of those. And let me go into this. Well, class administration. Student view. I'm never good at making up ones that come up as linear equations. So you got it. Okay. And textbook. Okay, so we got our equations, linear equations. I'm going to choose I'll choose 61. I wasn't choose 63 because it looks a little bit more interesting, but I'm afraid it might come up with a no solution. Sometimes they do when they get too complex. So 61. We got 2 over x minus 5 minus 1 over x plus 5 equals 11 over x squared minus 25. Step 1, get rid of parentheses. Don't have any. Step 2, get rid of fractions. First sub-step within that is to factor all your denominators. Now x minus 5 and x plus 5 I can't do anything with, but x squared minus 25 is difference 2 squares. 2 terms of minusing it. So this becomes 2 over x minus 5 minus 1 over x plus 5 is equal to 11 over x plus 5, x minus 5. Now B, we want to figure out our LCM of all our denominators. So we'll start with our first factor. So we're going to start with x minus 5. Let's make sure my little microphone is about the level of my nose, otherwise you hear my breathing instead of the talking. I start with the x minus 5. I'm looking for the greatest number of x minus 5s in a single denominator. There's one here, none here, one here. So the greatest number of x minus 5s in a single denominator is 1. Then I go to my next factor, the x plus 5, and I'm looking for the greatest number of x plus 5s in a single denominator. None here, one here, one here, so it'd be 1. And that would be our LCM. And that's what we're going to multiply everything by. So we'll multiply by our first fraction. We'll multiply it times our second fraction. And we'll multiply it times the fraction on the right side. When we do that, this x minus 5 cancels this x minus 5. This x plus 5 cancels that x plus 5. This x minus 5 cancels that x minus 5. And this x plus 5. This x minus 5 cancels this x minus 5. And this x plus 5 cancels that x plus 5. Let me write down what I have left before I multiply it through. 2 times x plus 5 minus 1 times x minus 5 equals 11. 2 times x is 2x. 2 times 5 is 10. Negative 1 times x is negative 1x or negative x. Negative 1 times negative 5 is a positive 5. Equals 11. 2x minus x is x. 10 plus 5 is 15. Equals 11. Now step 3. Solve for x. This is linear. The reason why I know it's linear is because it's x to the first power. We don't have an x squared. If we go through our 4-step method for solving a linear equation, get rid of parentheses, don't have any. Get rid of fractions, don't have any. Get everything with x on one side, numbers on the other side. So take that 15 over. Then it becomes a negative 15. Now we get 11 minus 15, maybe. There's one thing we have to do when we're dealing with rational equations. We have to check our answer. And not fully check it, but semi-check it. So if I put negative 4 back up my original problem, I put negative 4 here, I got negative 4 minus 5, that's negative 9. What we're looking for is to make sure that none of our answers cause the denominator to equal 0. So that answer is fine. If I put negative 4 here, negative 4 plus 5 is 1. That's not 0. If I put negative 4 here, negative 4 squared is 16. 16 minus 25 is not 0. I don't care what it's actually equal to. I just want to make sure it's not equal to 0. And that would be your answer. Now, next topic is solving linear equations for a specified variable. That would be like these down here. And we'll choose one of these to solve. Number 87 might not be too bad. Another word for literal equations is formulas. So solving formulas for a variable. Step 1. Get rid of parentheses. We do that via the distributive property again. Step 2. Get rid of fractions. Multiply by the LCM of all the denominators. Step 3. Get everything with the variable we are solving for on one side, everything else on the other side. Now those are going to be terms for the most part, but they don't have to be. As you get into more complex formulas, you might have items that are not terms. That's why I like to use this wording. Step 4, if possible, factor out the variable we are solving for. You will have 2 or more of that variable. And step 5, divide both sides by what is in front of / back of the variable we're solving for. Okay, so let me clear this off. And we got, I guess could do 84 first. You probably have more trouble with fractions. We need to see one of those. Step 1, get rid of parentheses. Don't have any. Step 2, get rid of fractions. Multiply by the LCM of all your denominators. We only have one denominator, the 3, so that is our LCM. So we'll take 3 times b, and we'll take 3 times 1/3 bh. You multiply 3 by what's separated by pluses, minuses, and equals. Now 3 times v is 3v. Over on this side, these 3's cancel, and we end up with bh. Step 3. Get everything with the variable we're solving for on one side, everything else on the other side. We're solving for b as in Bill. Everything with the b's on the right side, and everything else is over on the other side. Step 3, or step 4. If the variable you're solving for or factored out, if you got, if possible, how did I put that? If possible, factor out the variable you're solving for. You'll have 2 or more of them. We only have one b here. You'd have to have 2 b's. Step 5. Divide both sides by what's in front of / back of the variable we're solving for. We're solving for b as in Bill. There's nothing in front of it, but there's an h after it. So we'll divide both sides by h. And do that. Those h's cancel. And then we got b is equal to 3b over h. And that's our answer. Now let me look at another one. Number 87. We got 6x plus ay equals bx plus 5. Now step 1, get rid of parentheses. Don't have any. Step 2, get rid of fractions. Don't have any. Step 3, get everything with the variable we're solving for, which is solving for x. So we'll get everything with x on one side, everything else on the other. So I'll take this bx, move it over. Now I'll take this ay and move it over to the right side. Remember, when you move anything across your equals, your sign changes. So the positive bx becomes a negative bx. And over here, the positive ay becomes a negative ay. Step 4. Factor out the variable if possible, the variable we're solving for. We're solving for x, and I said you'll have 2 or more of them. See how we have 2 x's here? So we'll factor out an x. And that's going to give us 6 minus b equals 5 minus ay. Step 5. Divide both sides by what's in front of / back of the variable we're solving for. There's nothing in front of the x, but there's a 6 minus b after. So I divide both sides by 6 minus b. Although my 6's and b's look a lot alike. Six minus b's cancel there. And you got x is equal to 5 minus ay over 6 minus b. And that's your answer. And, okay, back to chapter 1. Now I'm going to skip over 1.2 and we'll go to complex numbers, 1.3. We just don't have time to show everything. Okay, complex numbers. They have something called standard form. And standard form is the form a plus bi, where a is your real part and the bi is your imaginary part. Now the question is, what is I? Besides saying it's your imaginary part. If you end up with the square root of -1, this is what's equal to I. So if you're working a problem, you come up with that, that's the I. Okay, for example, if I got square root of -12. If I break this down, -12 is -1 times 2 times 2 times 3. Now normally with square roots we're looking for pairs of something. Here's a pair of 2, so that's going to come out in front. And here's a -1, that's going to come out as an I. So we're going to have 2i, and then we're left with a 3 inside. So our answer would be 2i square root of 3. Technically speaking, standard form says your I has to be at the end like this. Either one typically is okay. I'm not sure what the online homework system was looking for. Now for the most part we treat i's like variables. So if I have 3 plus 5i plus 2 minus 6i, these parentheses aren't actually doing anything in this problem, so I can drop them. So I got 3 plus 5i plus 2 minus 6i. We will combine the like items. Here's a 3 plus 2, which gives us 5. And here's a 5i and a -6i. Since the i's are the same, we can add or subtract the numbers in front of them. 5 minus 6 is -1i, or just simply 5 minus I. And that'll be your answer. Grab a drink here. We have subtraction. 8 minus 2i minus 3 plus 7i. Now here the 8 minus 2i, parentheses doesn't do anything. Remember, if you have a negative in front of your parentheses, this flips the sign of everything inside. So positive 3 becomes a -3. The positive 7i becomes a -7i. Then we want to combine numbers. 8 minus 3 is 5. And combine i's. We got -2i and -7i. That gives us -9i. Now, next one we're going to take a look at is multiplication. And you need to know for multiplication that I squared is equal to negative 1. So don't worry about that overly, but that's something you'll use. The YouTube videos I put out there are going a little bit more detail than that. But if I have 3 plus 2i times 5 plus I, well, then we're going to use the same technique we did in multiplying polynomials together, specifically binomial times binomial. We'll take 3 times 5. First parts multiply together. We'll take 3 times I, the outer parts. 2i times 5, the inner parts. And 2i times I, the last parts. I'm just following these lines, taking 3 times 5 over here and times I. And then I'm taking 2i times 5 and times I. 3 times 5 is 15 plus 3i. 2i times 5 is 10i. And 2i times I is 2i squared. So that gives us 15. 3i plus 10i is 13i. And remember what I said up here, I squared is equal to negative 1. So we'll replace the I squared with negative 1. So that gives us 15 plus 13i. 2 times negative 1 is negative 2. 15 minus 2 is 13 plus 13i. And that would be our answer. Can't leave an I squared in there because that's not standard form. Standard form says the largest part of power of I is the first power. You can't have an I squared or I to the third or any of that. Actually, let me show one before that. I won't actually work this one, but I'll talk about it. If you have 2 plus 3i squared, what you have to do is you have to rewrite this first. 2 plus 3i times 2 plus 3i. And then it gives you the same result as what we just saw in the last example. So I won't finish that. But that's how you rewrite that one. Now division. If I have 3 plus I over I. If you have a single item in the denominator with an I, then you're going to multiply top and bottom by an I. Always. So that's going to give us I times 3 plus I times 3 plus I, and down below I times I, which is I squared. Now I times 3 is 3i, and I times I is I squared over I squared. Now remember what we set up above, what I squared is equal to. So we can replace those I squareds with negative 1. And then if I divide both these by negative, 3i divided by negative 1, and negative 1 divided by negative 1, we're going to end up with negative 3i plus 1, or 1 minus 3i, putting it into standard form. Let me clear this page off. I don't think, I might have room. Now if you got two items down below, for example, you have 3 minus I. So you got two pieces. One of them has an I. What you do is you multiply top and bottom by the conjugate of the bottom. This is 3 minus I, so our conjugate would be 3 plus I. Now how the conjugate works is the first part's the same, 3 and 3. The last part's the same, I and I. But the sign in the middle is different. This is a minus and this is a plus. Now whatever we multiply by the bottom, you have to multiply by the top. Now I'm going to stop sharing here and then share again. This tends to time out if I don't have some kind of activity. So I'm going to take 2 plus I over 3 plus I. And down below I'll have 3 minus I over 3 plus I. Up on top, that's just foiling again, multiplying those together. I got 2 times 3, which is 6. 2 times I, which is 2i. I times 3, which is 3i. And I times I, which is I squared. And down below, since these are conjugates, with conjugates you multiply the first parts together and last parts. So I got 3 times 3 and negative I times I. That'll always occur when you have conjugates. Let's see, 2i plus 3i is 5i, and I squared is negative 1, so we replace I squared here with negative 1. 3 times 3 is 9 minus I times I, which is I squared. Back up on top, 6 minus 1 is 5, so we got 5 plus 5i over 9 minus, and I squared is equal to negative 1. So we got 5 plus 5i over 9 plus 1. Remember, a negative negative becomes positive. We got 5 plus 5i over 10. Now we want to split this up. The standard form says real part has to be separate from the imaginary part. So I'll do 5 over 10 plus 5 over 10i, which gives us 1/2 plus 1/2 I. And that's our answer. Now we have powers of I. I to the first is 1. Let's try it again. I to the first is I. I squared is equal to negative 1. I to the third is negative I. I to the fourth is positive 1. I to the fifth is I. I to the sixth is negative 1. I to the seventh is negative I. I to the eighth is 1. And it repeats in the same pattern over and over, groups of 4. Now if you have like I to the 101st power, you probably don't want to build this table out so far to where you can see 101. There's a shortcut to it that we're going to talk about. What you do is you divide by 4. This is old style division. 4 goes into 10 2 times. 2 times 4 is 8. Subtract that. 10 minus 8 is 2, and I carry it down to 1. 4 goes into 21 5 times. 5 times 4 is 20. Subtract that, and we get 1. That 1 would be our remainder. If you got I to a power, you can divide by 4, and then you can rewrite this as I to the remainder. Well, we said remainder is 1, so that becomes I to the first power, and I to the first power from up above is just simply I. And that would be our answer. Let me clear those off, and that's complex numbers. I guess I can grab a drink while it's clearing. There we go. And we'll be taking a look at quadratic equations next. And the first thing we'll look at is something called the zero product property. So zero product property. And it says if you got something times something else equal to 0, then you can set each factor equal to 0. That's really vague. Something times something equals 0. It is that vague. As long as you have 0 on the right side and then you got this written as a product over here. That's also called a zero factor property. I think that's the way I referred to it in the video. So for example, I got x squared minus 7x plus 10 equal to 0. First thing, have to have 0 on the right side, or any side, which we do. We have 0 on the right side here. Our second step, we need to write this as a product. Well, this can be factored. And this will be the PST method because it's x squared x, no number in front of our x squared. And this factors as x minus 5 times x minus 2 equals 0. Now our zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x minus 5 equal to 0, and I'll set x minus 2 equal to 0. And then you solve those, and I get x equals 5 and x equal to 2. And those would be my answers. Now that's a zero product property. Next thing we're going to take a look at is the square root property. Let's say we have, or let's better write property up first. Square root property. This says if you got something squared equal to something else, that's pretty vague, then you drop your squared and you put a plus or minus square root on the other side. For example, if I have x squared is equal to 25. Well, this property says that the entire left side has to be squared. Well, the entire left side is squared. Then we're going to drop the squared, and you always put a plus or minus square root on the other side. Now, plus or minus doesn't mean you get to choose one or the other. You have to put that entire symbol. Now remember, we always simplify square roots, or radicals. 25 is 5 times 5. And remember, the square root will look for a pair of somethings. Here's a pair of 5s, so they're going to come out in front as a single 5. And we got x is equal to plus or minus 5. Now what that plus or minus means is we're going to have x equals negative 5 and x is equal to positive 5. Now if I have x plus 3 squared is equal to negative 12. Square root property is pretty clear. It just says if you have something squared equal to something else, it can be anything. Well, this entire left side squared here, because remember the exponent only affects what's to its immediate left unless there's parentheses, and then affects everything inside the parentheses. So square root property, drop your squared, put a plus or minus square root on the other side. We always simplify radicals. Negative 12 is negative 1 times 2 times 2 times 3. Remember, we're looking for a pair of something. So here's a pair of 2s, so they're going to come out in front. And here's a negative 1, not come out as an I. So we got x plus 3 is equal to plus or minus 2i square root of 3. And then I'll take the 3 over, and we get x equals negative 3 plus or minus 2i square root of 3. We could put the I after the square root of 3 if you wanted to, but that would be our answer. Now let's talk about some simplifying. You're working a problem down, and you get it to the point where you have x is equal to 3 plus or minus 5 over 8. Notice that our radical disappeared. If your radical disappeared and you don't have an I, that's where you want to split it up. What that plus or minus means is we're going to have x is equal to 3 plus 5 over 8, and we'll have x is equal to 3 minus 5 over 8. 3 plus 5 is 8, so we'll have 8 over 8. And 3 minus 5 is negative 2, so we'll have negative 2 over 8. 8 divided by 8 is 1, and negative 2/8 reduces to negative 1/4. So in that case, we want to split the answer up. Let me clear off that page. And okay. Just don't want that timeout. That's why I was doing some kind of activity. We're going to take a look at completing a square now. Let's see, completing the square. Step 1, divide everything, all the terms, divide everything by the number in front of the x squared. That would be called the coefficient. Step 2, take the number, the constant term, to the right side. Step 3, take the number before the x, that would be the coefficient, multiply it by 1/2, square it, and then add to both sides. Step 4, back to the left side. Step 5, use the square root property to solve for x. So let me make up a problem. I got x squared minus 4x minus 10 equals 0. Step 1, divide by the number in front of the x squared. There is no number in front of our x squared. Step 2, take the number of the constant term, which is negative 10, move it to the right side. So we'll have x squared minus 4x is equal to 10. Remember, when you move anything across or equals, your sign changes. Step 3, take the number before your x, which is negative 4. You multiply it times 1/2 and you square it. It's always times 1/2, it's always squared. Negative 4 times 1/2 is negative 4/2, or negative 2 squared, which gives us a positive 4. And then add that to both sides. So we're going to have x squared minus 4x plus 4 is equal to 10 plus 4. So that gives us x squared minus 4x plus 4 equals 10 plus 4, which is 14. Step 4, factor the left side. This factors as x minus 2 squared equals 14. Now there's a trick to help you on that. Whatever number's right here, sign included right before you square it, is always what goes right here. If you remember that, there's no factoring involved at all. Step 5, use the square root property to solve for x. We got something squared equal to something else, so we'll drop our squared, and we'll put a plus or minus square root around the other side. Now we can't simplify the 14. Now 14 is 2 times 7. But we can solve for x, so I'll take the negative 2 over. Then we got x is equal to 2 plus or minus square root of 14. And that's our answer. Now that's the easiest type that I'm showing there with the even. We really don't have time to show the medium and hardest type. If you watch YouTube videos that I put out there, you'll see those types on there. So let me erase that. And let's talk about the quadratic formula. Quadratic formula is used whenever you have the form ax squared plus bx plus c equal to 0. A, b, and c are typically numbers, and you have to have a 0 on the right side. If you have in that form, then your answer is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. For example, I have 5x squared minus 2x plus 7. Well, let me change that 7 to a 1. Want to make sure I come up with something that you can't actually solve with another method. I mean, you can solve by completing a square, but I mean where you can factor it. Okay, first thing we need to do is identify our a, b, and c. A is whatever number is in front of our x squared, the coefficient, which is 5. B is whatever number is in front of our x, which is negative 2, coefficient. And c is our constant term, the number at the end, which is 1. Notice how the sign comes along with it. Now I'm going to go to my quadratic formula. I'm going to replace all my variables with sets of parentheses. So I got negative b plus or minus square root of b squared minus 4 times a times c all over 2a. Now b we said was negative 2, so everywhere I had a b in my formula I put in negative 2. A was 5, so everywhere I have a a in my formula I put in 5. And c was 1, so I'll put a 1 where the c was. And then we simplify. Negative negative gives us positive 2, plus or minus. Negative 2 squared is 4, minus 4 times 5 times 1 is 20, over 2 times 5, which is 10. So we got 2 plus or minus 4 minus 20 is negative 16 over 10. You always simplify your radicals at any point. Negative 16 is negative 1 times 4 times 4 all over 10. We always, like I said, we always simplify it. So I'm going to take the pair of 4's out. I'm going to take negative 1 out. In this case, the radical is going to disappear. So we got 2 plus or minus 4i all over 10, and that disappears. Now whenever you have an I appear in your problem, you want the real part separate from the imaginary part. So put the 2 over 10 plus or minus 4 over 10 with an I to the side. And those fractions simplify. 2/10 reduces to 1/5 plus or minus 2/5 I. And that would be our answer. Now I'm going to write up the rules for the discriminant. I'm not going to show a problem dealing with that. I just want to make sure I have enough time to show what I need to. Though I always run out of time anyway, but discriminant. If you have something of the form ax squared plus bx plus c equals 0, then your discriminant is going to equal to b squared minus 4ac. It's just a piece of the quadratic formula. Then you have 3 cases. Case 1. The discriminant is greater than 0. This tells you what kind of answers you're going to have. If it's greater than 0, it means I'm going to have 2 answers, and they're going to be real. Case 2, our discriminant is less than 0. That means you're going to have 2 answers, and you'll have an imaginary part. Some books mistakenly state that you're going to have 2 complex numbers. That's not technically correct, because every real number is a complex number. So to say the number 3, that is a complex number, even though it doesn't have an I. The important part there is you're going to have an imaginary part. And then if your discriminant is equal to 0, you're going to have 1 answer. It'll be real, and it'll be repeated. You might have like x equals 2 and x equals 2. So that's our discriminant. Now I'm going to skip over these applications here. And let's go down to 1.6. Solving polynomial equations. And hopefully my ebook hasn't went away. That must be the more equations than inequalities. Current session is closed. It did expire. Log in again. Okay. And student view. Chapter 1 and 1.6. There we go. I guess number 12 is good as any. Let's see, number 12. We got 98. I don't like t's though, so we put x's there. X to the third minus 49x squared minus 8x plus 4. Now we want to solve this, and this is a little bit harder than the previous problem we looked at, where you got 0 on one side and then you factor the other side. This factors by grouping. So group first two terms together, group last two terms together. First group here has a 49 and x squared in common. That gives us 2x minus 1. Second group has they're both divisible by 4 and the first term is negative. So it has a negative 4 in common. So I'll factor that out. And that gives us 2x minus 1. Now our goal was to get the 2x, the parentheses is the same here, the 2x minus 1s. So I'll factor that out. And that leaves us 49x squared minus 4. So that's grouping. Now we're going to use difference two squares. Because 49x squared minus 4, that's two terms of minusing it. And I won't go through all the steps, but that gives us 7x plus 2 and 7x minus 2. Throughout the rest of the course, I always write down what technique I use for factoring, so you can go back later and do it yourself. But I won't always show the steps anymore like I did in the first session. Okay, zero factor property. It's back to that. It's still the same. Or you could call it a zero product property. That's up to you. It says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I set 2x minus 1 equal to 0, 7x plus 2 equals 0, and 7x minus 2 equal to 0. Then you solve those. Here I'll take negative 1 over, it becomes a positive 1, divide both sides by 2, you get 1/2. Here I'll take 2 over, it becomes a negative 2, divide both sides by 7, and you get negative 2/7. Here I'll take a negative 2 over, it becomes a positive 2, and divide both sides by 7, and you get x equals positive 2/7. And those would be our three answers. Let me erase that. And these next problems, well, actually I should look, I guess. I say solve rational equations. You might say, well, we solved rational equations up above. No, that was right up here. Well, these are rational equations that lead to linear equations. These should lead to quadratic equations. It's exact same steps. Let's take a look at number 20. See how it differs. 4c over c minus 5 minus 1 over c plus 1 equals 3c squared plus 3 over c squared minus 4c minus 5. Now, if you remember our steps for solving a rational equation, first step is get rid of parentheses. Don't have any. Second step, get rid of fractions. And then the first substep within that said to factor all your denominators. C minus 5 and C plus 1 I can't do anything with. But this is the PSD. Because we have C squared, C, no C, and there's no number in front of your C squared. So we got 4C over C minus 5 minus 1 over C plus 1 equals 3C squared plus 3 over C minus 5 times C plus 1. To B. Figure out your LCM of all your denominators. Start there. We'll start with our first factor, C minus 5. I'm looking for the greatest number of C minus 5s in a single denominator. There's one here, none here, one here. So my greatest number of C minus 5s is 1 in a single denominator. C plus 1. I'm looking for the greatest number of C plus 1s in a single denominator. None here, one here, one here. So the greatest number of C plus 1s is 1. Now that would be our LCM. And that's what we're going to multiply everything by. We'll multiply by our first fraction by 4C over C minus 5. We'll multiply it times our next fraction. And you can put it after it if you want. You don't have to put it in front. Multiplication is commutative. And then we'll multiply it times the fraction on the right side. When I do that, this C minus 5 cancels that C minus 5. This C plus 1 cancels that C plus 1. This C minus 5 cancels that C minus 5. This C plus 1 cancels that C plus 1. So we're left with 4C times C plus 1 minus 1 times C minus 5. And over on this side we got 3C squared plus 3. Now 4C times C is 4C squared. 4C times 1 is 4C. Negative 1 times C is negative 1C. Negative 1 times negative 5 is a positive 5. Equals 3C squared plus 3. 4C minus 1C is 3C. Plus 5 equals 3C squared plus 3. And now we're at step 3. Solve for x. This is a quadratic. Reason why I know it's a quadratic is it's got a c squared. When you have the second power, that means it's quadratic. Well, with quadratics, we want to get 0 on one side, everything else on the other side, and then we'll hopefully factor it. So I'll take 3c squared over, and I'll take the 3 over. Remember, when you take anything across your equals, your sign changes. So I got 4c squared minus 3c squared plus 3c plus 5 minus 3 equal to 0. 4c squared minus 3c squared is c squared plus 3c, 5 minus 3 is 2, equals 1. Now we want to factor this. This factors using the PSD, factors as c plus 1 times c plus 2. Now zero product property or zero factor property, you get 0 on one side, you factor the other side, you set each factor equal to 0. C plus 1 equal to 0 and C plus 2 equal to 0. Take the 1 over, becomes a negative 1. Take the negative 2 over, becomes a negative 2. And these are our answers maybe. We have to plug them back into our original problem and make sure they don't cause any denominator equals 0. Let's start with the negative 1. I'll put negative 1 back up here. Negative 1 minus 5 is negative 6. That's okay. If I put negative 1 here, negative 1 plus 1 is 0. That would cause division by 0, so we can't have that answer. Negative 2. Negative 2 minus 5 is negative 7. That's not 0. Negative 2 plus 1, that's negative 1. That's not 0. Negative 2 squared is 4. Negative 4 times negative 2 is 8. 4 plus 8 minus 5, I don't know what it is exactly, but I know it's not 0. That's the only thing you're checking. So C equals negative 2 is our answer. Let me erase that. we go. Now we're taking a look at radical equations. So solving radical equations. Our first step is to get a radical by itself on one side of the equals. We'll talk more about what does that mean. Step 2 is to raise both sides to a power equal to the index. Step 3, if more radicals, go back to step 1. Step 4, solve for x. That's pretty vague, but again at this point it could be a linear, and that's use the 4-step method we've looked at earlier. Or it could be quadratic and use zero product property, zero factor property that we looked at earlier. And step 5 is check your answers. Now this time you have to fully check it. You just don't check it to make sure it doesn't cause 0 in the denominator. Okay, so let's come back here and we find one. Take a look at number 33. Square root of m plus 18 plus 2 is equal to m. Step 1. Get a radical by itself. Well, this isn't by itself. We've got a plus 2 over here. So to get it by itself, we can always do the opposite operation. That's adding 2, so we're going to subtract 2. Or you can simply just take 2 and move it over to the right side. So we got square root of m plus 18 is equal to m minus 2. Step 2, raise both sides to a power equal to the index. Now index is whatever number's in the slot right here. And you notice I don't have a number in a slot. When you don't have a number there, it's a square root, so it's by default 2, which means I'm going to square both sides. So I got a square root of m plus 18 squared is equal to m minus 2 squared. Now whenever your index matches the power, they cancel each other away. So that gives us m plus 18. And over on the right side, m minus 2 squared we can rewrite as m minus 2 times m minus 2. Well, m times m is m squared. M times negative 2 is negative 2m. Negative 2 times m is negative 2m. Negative 2 times negative 2 is 4. So we got m plus 18 is equal to m squared minus 4m plus 4. Now step 3. If you have more radicals, go back to step number 1. We don't have any more radicals. Step 4. Solve for x. Well, this is a quadratic. The reason why I know it's a quadratic is because it's got second power, m squared. And for a quadratic, we have to get 0 on one side. So I take the 18, move it over, take the m and move it over. So we're going to have 0 is equal to m squared minus 4m minus m plus 4 minus 18. And we get m squared. Negative 4m and negative m is negative 5m. And 4 minus 18 is negative 14. This will factor using the PSD. Now factor is m minus 7 times m plus 2. Get 0 on one side, you factor the other side. We said each factor equal to 0. M minus 7 is equal to 0. M plus 2 equals 0. Which gives us m is equal to 7 and m is equal to negative 2. Maybe. Because remember our last step is to check our answers. If I put 7 up here, 7 plus 18 is 25. Square root of 25 is 5. So you got 5 plus 2, which is 7. If I put 7 here, I get 7 equals 7. So that checks. Now negative 2. Negative 2 plus 18 is 16. Square root of 16 is 4. So we got 4 plus 2 on this side. And if I put negative 2 over here, I'd end up with 6 equals negative 2. So that one doesn't check. So our only answer is the 7. And that's our radical equation. Now there's the equations with rational exponents. And that would be that'd be like 43 and 44, or maybe this one. Actually, there's quite a few here that may fit. So let's talk about those. Solving equations with a single fractional power. Now, a fractional power is called a rational exponent. Step 1. Get the part with the single fractional power. Guess I ought to say single fractional power up here. Get the part of the single fractional power by itself on one side. We'll see an example then. Step 2. Raise both sides to a power equal to the reciprocal of the fractional power. If the numerator is even, then you're going to put a plus or minus. If the numerator is odd, then you're going to put no plus or minus. And then step 3, solve for x. Although it can mean a variety of different things, the two main things it means now, it'll be linear, and use the 4-step method. Or it could be quadratic, and you use the zero product property. Okay. Let's look at number 43 to see the difference on those. I don't want to spend a huge amount of time since I'm running out of time. I only got 21 minutes left. M to the 3/4 is equal to 5. Okay, step 1, get the part of the fractional power by itself one side. It's by itself, so that's done. Step 2, raise both sides to a power equal to the reciprocal. Well, this is 3/4 power, so reciprocal will be 4 over 3. You flip the fraction. And you take this to the 4 over 3 power. Now, I refer to the number, the numerator's even, the numerator's odd. So I refer to the number up on top here. Notice that this is odd, which means no plus or minus. Now the 3's cancel here, the 4's cancel, and we got m is equal to something. What's it equal to? Solving a radical equation, both sides. Doesn't say what type to put it into for your answer. Since it doesn't say, 5 to the 4/3 power is actually perfectly fine for your answer. Let's say I will look at B. m to the 2/3 is equal to 5. Well, our second step, first step is get the part of the fractional power by itself. There's nothing in front of it, nothing after it, so that's done. Step 2, raise both sides to a power equal to the index. So we got m to the 2/3, and we're going to raise both sides to the 3/2 power. But on this one, the number up on top is even, which means we're going to put a plus or minus. So if there's a plus or minus comes into the problem right here. 2's cancel, 3's cancel, and we have m is equal to plus or minus 5 to the 3/2 power. So that's what we mean by the odd and even on those. Okay. Solve equations in quadratic form. That'd be like number 49. We'll take a look at that. No, that wouldn't be. I lied to you. Here they are. Down here, like number 56 or 59. This is solving using the U-Substitution. It's also referred to as equations quadratic in form. Step 1. Let the middle part be equal to u, and the first part be equal to u squared. It never includes the number in front of that part. You can think of that as a coefficient. Although these won't always be terms. Step 2, solve for u, whatever that means. Step 3, plug u equals blank back in and solve for x. Pretty vague process, probably the most vague process in algebra. Has to be for a reason. Let me clear this off. And let's take a look at number 56. We got y squared minus 3 squared minus 9 times y squared minus 3 minus 52 equals 0. Now when you can use the U-substitution is if you can take the middle part, excluding the number in front, if you can take the middle part, square it, and it gives you this first part, that's when you can use it. Step 1. Let the middle part be equal to u, never includes a number in front, and the first part be equal to u squared. So this automatically gets rewritten as u squared minus 9u minus 52 equals 0. Now step 2 is to solve for u, and this will factor, I think, using PSD. Will it factor? 1 times 52, 2 times 26, 3 times, well, I can't see it for some reason. I did go out of town this weekend, so I'll blame it on being tired. Nope, it's not divisible by 3. 4 times, let's see, 1, and then 12, 13. There it is. Okay, so this factors as u minus 13 times u plus 4 equals 0. We get 0 one side, we factor the other side, we set each factor equal to 0. So I'll set u minus 13 equal to 0 and u plus 4 equals 0. Take the negative 13 over, it becomes a positive 13. Take the 4 over, it becomes a negative 4. Step 3, plug u equals blank back in and solve for x. Every problem will be different. Whatever you said u is equal to right up here is automatically we're going to plug in for the u down here. we said u is equal to y squared minus 3. So we got y squared minus 3 is equal to 13, and y squared minus 3 is equal to negative 4. Now here I'll take negative 3 over. It becomes a positive 3. Immediately when I put that in there, I didn't think that originally when I started solving this problem, but I was thinking when I plug that back in, this is a square root property because the middle term's missing. Here I'll take negative 3 over, and it becomes a positive 3, which gives us negative 1. Square root property. You got something squared equals something else. You drop your squared, and you put a plus or minus square root on the other side. Drop your squared, put a plus or minus square root on the other side. Now 16 is 4 times 4, so square root of 16 is 4. And remember, a negative 1 inside of your square root gives you an I. So those would be our 4 answers. Assuming imaginary is okay. Make an appropriate substitution and solve the equation. Doesn't say anything about that your answers have to be real. Okay, linear inequalities in one variable. And let me clear this off. So solving linear inequalities in one variable. Step 1, get rid of parentheses. We do that via the distributive property again. Step 2, get rid of fractions. We multiply by the LCM of all the denominators. Step 3, get everything, talking about terms, with an X on the left side, numbers on the right side. Step 4, divide both sides by the number in front of the X. We have a note down here that says if you multiply or divide both sides by a negative number, you flip the inequality symbol. Okay, so we got 5 times x minus 1 is less than negative 7x plus 2. Step 1, get rid of parentheses. Now we'll take the 5, multiply times x times negative 1. 5 times x is 5x, 5 times negative 1 is negative 5. And everything else carries down. Step 2, get rid of fractions. Don't have any. Step 3, get everything with an x on the left side, numbers on the right. So I'll take negative 7x, move it over. I'll take negative 5, move it over here. You take anything across or equals, your sign changes, so negative 7x becomes a positive 7x, and a negative 5 becomes a positive 5. Combine like terms. 5x plus 7x is 12x. Combine numbers. 2 plus 5 is 7. Step 4. Divide both sides by the number in front of your x. So we'll divide both sides by 12. Those 12s cancel. Then we got x is less than 7/12. And that would be our answer. Just running out of time here. Let me show a compound linear inequality. So solving a 3-sided compound inequality. Step 1. Get rid of parentheses. Step 2, get rid of fractions. We still get rid of those the same way as before. Step 3, get everything with an x in the middle, numbers on the other two sides. Step 4, divide all three sides by the number in front of the x. And then our note, if you multiply or divide all three sides by a negative number, you flip inequality symbols. Clear that off. For example, if you have negative 3 is less than 4x, minus 5 is less than 6. Step 1, get rid of parentheses. Don't have any. Step 2, get rid of fractions. Don't have any. Step 3, get everything with an x in the middle, numbers on the other two sides. So instead of taking negative 5 over just the other side, we have to take it over the other two sides. It's equivalent to adding 5 to all three sides. So I got negative 3 plus 5 is less than 4x, is less than 6 plus 5. Negative 3 plus 5 is 2, is less than 4x, is less than 11. And then our last step, divide both sides, or divide all three sides by a number in front of your x. Number in front of our x is a 4, so we'll divide all three sides by 4. 2/4 reduces to 1/2, is less than, those 4's cancel, x is less than 11/4. And that would be our answer. And just to work some problems real quick on these last ones, we're obviously not going to be able to show much in terms of time. But if you got an absolute value equation, absolute, something I can spell, absolute value equation looks like this. It says if you got the absolute value of something is equal to something else. It really is as vague as that. You just can't have anything in front of it, anything after it. Then you drop the absolute value, set it equal to the positive the other side, drop the absolute value and set it equal to negative the other side. An example, if you have 3 and then absolute value of x minus 1 minus 4 is equal to 2. Well, first off, we have to get the absolute value by itself. So you always do the opposite operation. So here I'd add 4 to both sides, because this is a minus 4, so we add 4. And then negative 4 plus 4 cancel each other out. That's the opposite operation. 2 plus 4 is 6. Now the opposite operation here, this is 3 times. So the opposite operation is division. So we divide both sides by 3. And you always do it in this order. You always do the addition and subtraction first, and then your multiplication and division. That may sound kind of weird based upon our order of operations, but those 3's cancel, and 6 divided by 3 is 2. And now it's in the right form. We got the absolute value of something is equal to something else. What's inside of our absolute value is our p, and the other side is your q. And then you plug in your formula. P is equal to q, p is equal to negative q. So everywhere I have a p, I'll plug in x minus 1, and everywhere I have a q, I'll plug in 2. So I got x minus 1 is equal to 2, and x minus 1 is equal to negative 2. And then you solve each one of these, and you get x equals 3, and then this one you get x equals negative 1. And those will be your answers. Okay. Absolute value inequalities. Like I say, the YouTube videos I put out there go into much more depth. There's two cases of absolute value inequalities. Case 1 was where you have the absolute value of something is less than something else. If you have it in that form, then you rewrite it as negative q is less than p is less than positive q. And case 2 is where you have an absolute value of something is greater than something else. If you have it in that form, you rewrite it as p is less than negative q, and then there's no or here, and p is greater than positive q. So for example, if I had the absolute value of x minus 3 is less than 7. Well, the absolute value is by itself on the left side, nothing in front of it, nothing after it. So what's inside our absolute value would be our p. By the way, if we did have a number in front of it, a number after it, you get rid of it the same way we did the last problem. And the other side will be our q. Our formula says we got negative q is less than p is less than positive q. So I'd have negative 7 is less than x minus 3 is less than positive 7. Take negative 3 over to the other two sides. So we'd have negative 7 plus 3 is less than x is less than 7 plus 3. Which gives us negative 4 is less than x is less than 10. And that would be our answer. There's lots of different forms, set builder, interval, graph. No time to cover those, but you'll see them in the video. Now on the other hand, if I have an x plus 2 is greater than or equal to 5. If you have a line underneath, well, it's still the greater than case here, but if there's a line underneath in our problem, you put a line underneath here. You'd also put a line underneath here and here. No book ever writes all four formulas, but it's assumed that's true. This will be our p, and this will be our q. And our formula is p is less than or equal to negative q, and there's no or here. P is greater than or equal to a positive q. So everywhere I have a p, I'll plug in x plus 2. And everywhere I have a q, I'll plug in 5. And then we'd solve each of those separately. So I'll take 2 over. So we got x is less than or equal to negative 7. Here I'll take 2 over, and we got x is greater than or equal to 3. And this would be our answer. Different ways you could write that. Basically, that's our answer. And I didn't think we were going to do it, but we finished all the material. We skipped some items, but let me go ahead and stop the video here, and then I'll answer any questions.